So the easiest of the volumes that you need to know is the rectangular box. And for that volume, we just do length times width times height. This is one that you've probably seen as early as grade school, perhaps or as early as single digit grades. Anyway, the next example is the cylinder. So the cylinder is described on the side here. We have a circle cross section and then a height h. So the cylinder is going to be pi r squared h. Now I'm not going to just recite the formula, especially for this one. I will give you some information here. So this is the base of the cylinder, and that's the height. This area here, if it's not a circle, you can still find the volume using a similar approach, because ultimately any cylinder belongs to a larger family of shapes called prisms. So here's a prism. A prism, or if you want a parallel solid, is an extension of cylinders, and it covers cylinders, but any other shape that has the following property. It has a cross section that doesn't change, so as you go up and down through the surface, through the volume, that the cross section remains the same. Another way to say it is that these lines here that extend to form the third dimension, those lines are all parallel. These are all parallel. So that's why it's called a parallel solid, because to extend it to 3D, it's done through parallel lines. This solid can be vertical, like right angled. See here, there's a right angle tucked in here. So it can be like that. It could also be slanted. You could have a slanted parallel solid. Whether it's slanted or vertical, the volume is the same. So it doesn't matter if the solid is slanted or vertical, you'll see the same thing. You'll have the same volume. So ultimately what you want to do here is take the area of the base. So you want this area here, which they call it B, and you want to multiply it by the height. So that's what the formula is here. See, the base times the height. If you go back to the previous page and you look at the cylinder, that's exactly what we have here. See, pi r squared, that is the area of the base. So if we did base times height, then this b is pi r squared. So we could have actually I could have completely ignored cylinders and said to you, oh, you don't need to know formula for a cylinder because it's already built into parallel solids. But you know the cylinder formula, or you probably have seen it many times, and that's something that you remember anyway. So when you want to find the volume of a shape like this, and we will practice a few of these today, at least two, sorry, what you want to do is just find the cross-sectional area and then multiply it by the height. In this case, the height is represented into the page like a depth. So the word height is used loosely here. It's just all a matter of in which perspective you present it. After parallel solids, so remember parallel solids are when the edges vertically run parallel to each other. In terms of a solid where they're not parallel, imagine that they weren't parallel. They would kind of like, you see how they would kind of converge maybe? Then you get shapes like cones and also pyramids. Now, there's no pyramids in this booklet as far as I remember. But anyway, we'll go to some curved three-dimensional solids, and we have here a cone. So the cone is a third of the cylinder. So if you have a cylinder, so a cylinder, recall, was pi r squared h. That was the cylinder. With a cone, it's going to be 1/3 of the volume. So just remember there's a factor of a third. Again, I'm just going through these individually and just cataloging them one at a time. My primary goal will be to just do exercises with you so that you can practice a lot. Two more formulas to cover, and then we're ready to do exercises for the rest of today. A sphere. I believe that I've given you the volume of a sphere on an assignment. So this is a formula that we at least have seen in passing earlier in the semester. Ultimately, the volume of a sphere is given below here. It's 4/3 pi r cubed. One thing to remember is that when you have questions or formulas involving volumes, that you expect the exponents on the variables to add up to 3. So you see here, look at that. We have r, r, r. See, r to the 3. So 3 of them. Similarly, when you had the first example, length times width times height, again, these are all to the 1. The exponents add to 3. You're always looking for third dimension. Even in the question for the prism, the base B is actually an area, so it does contain units squared within it. One last formula to kind of tie things together, because in construction we understand that it's not just about measuring volumes, but using those volumes to access information about other things. For example, finding out the weight of an object or the mass of an object. Perhaps it's the cost of an object. So if you have a certain volume that you need to fill with concrete, what would be the mass of the concrete that you would put in there, or even the cost? What would it cost you? So those things are related to the material itself. And one thing that is important to remember is that mass and weight are being used very loosely here. I'm going to be using the word mass more often than the word weight because they are not identical. But the key formula is right here. This guy right here, okay? This is a formula that is less common for people to remember. I'll type it in English and then I'll explain what it means there. So at some point in your life, you would have seen this formula. Let me know in the chat. Do you remember anywhere in your life seeing the formula for density? Who's seen density in their life somewhere? Yep, I got Nicholas there. Anybody else seen density? Okay. So it's important that we remember the formula for density because density is the bridge, if you want, between the volume or space that is occupied. Oh yeah, definitely in physics. I can second that one. Just a second. I'm gonna have a sip of my coffee. So my coffee, which has a density that's slightly heavier than water. Anyway, there you go. So hopefully we've gone through these and you've kind of remembered that there's little formulas here and there that you're going to have to use. In the notes on pages 24, 25, 26, you can see on the side here, look at all these pictures. We have 24, 25, 26, 27, 28. It just keeps on going, okay? So what we're going to do now is I just cherry picked up, I don't know how many here. I think I picked about 10 questions. We're going to take it nice and slow and see how far we can get through this stuff. So the ones that I've highlighted in blue represent roughly about a third of the questions. So we're going to do about a third of the exercises today. And that's it. And after that, there's another section after, which is just extra questions. If I just keep on going here, there's some extra challenge questions. Nothing too dangerous. I try to pick a variety of questions that goes from really easy to more complex. But honestly, I'm not trying to destroy anybody on the next test. I'm just giving you a nice medley of questions. As you know, you do have two math courses in this program. This is Math 1136. In the second course in Math 1146, which I will be teaching next semester. So if anybody wants to have me as their prof again, you can check me out in the Stu view when you're planning your courses. I'll appear somewhere in there. Anyway, I'm gonna give you guys a minute. I want you to figure out this question. I'll stop talking and we'll resume class in about 2 minutes, okay? So just try this question on your own for a couple of minutes. Okay, welcome back here. I just wanted to give you a little bit of a head start on this. Ultimately, we're talking about a rectangular room. So as we do these questions, I will type the formula here so that we don't have to jump back and forth in the notes. So what's the volume? It's length, width, height. Before we actually plug in the volume, let's just write down the length, the width, and the height. 1380. Nicholas, nicely done. Marco, you're close. So the first thing here is we have 16 feet, 11 feet. Ew, this one's annoying. I'm seeing all these answers. I'm getting overwhelmed. Thank you. But those are the values that I've just accessed from the question. And yeah, it's length times width times height. But we're going to talk about this thing here. Okay, 11 feet 6 inches is, okay, it's very convenient. It's 11 and a half feet. And this is going to be 7.5 feet. Thank you, Huria, and thank you, Nicholas. Yeah. So if anybody here, did anybody make the rookie? You don't have to say it in the chat, but did anybody make that rookie mistake and put 11.6? If you put 11.6, you fell into the trap. You fell into the trap, okay? So don't fall into the trap. Remember that inches, you got to divide by 12. Because you got to do this. You got to do 11 plus 6 over 12. That's the calculation, okay? 7 plus 6 over 12. Okay, so at this point, yeah, and 6 inches is half a foot. That's why I was so happy about this question, because it was very nice numbers. Okay, and yeah, anyway, let's do that. So just checking something. Yeah, it's 1380 is what I got as well. And that's in cubic feet. Make sure that you put units on your answer. That's obviously very important in terms of the work that we do together. Normally, I would write my answers vertically, but I don't have a lot of space to write these questions, so I'm going to be writing them sideways if you don't mind. Kind of when you see solutions to assignments, I kind of try to squeeze it into the box with the keyboard. Okay, anyway, that was 1A, a little icebreaker for you. And then we're gonna do now 1B. So let's go to 1B. What the heck happened there? Oh yeah, because I had cut out some text there. Okay, good. So if the air conditioning system for this room can move 2,500 cubic feet per hour, then how long does it take to exchange the air in the room completely? So you can see how unit conversions and the calculations with volumes, as they were with areas also last week, they're not disjoint. In other words, just because this is a volume question doesn't mean that you throw away unit conversions. We actually did a unit conversion in the previous part. We had to convert the inches into feet. And in this part of the question, you also need to consider conversion. So let's talk about what are the quantities that were given, okay? We know the following, we know 1380 cubic feet, and we also know 2,500. Oops, let me just equation mode that. 2,500 cubic feet per hour. So how do we take these two quantities and put them together to figure out the answer? So the question is how long? And when you're reading these questions, try to find those keywords. And here, how long? Yeah, you're going to do division here. But I'm gonna do something a little bit more kind of stable, because if you're like, okay, I get it, you're gonna divide something, but which way do you divide it? Thank you, Nicholas. Yes. Oh, also convert that into minutes, okay? Don't forget the minutes part. We'll get to that. Anyway, I'll show you what I would do is as follows. I'm gonna write down this. I'm gonna say that we do 1 hour. 1 hour is worth 2,500 cubic feet of processing or moving air. So what I'm doing is I'm taking the second quantity and I'm writing it upside down because I know that hours is the thing that I want. I want hours. And then what I can multiply by is 1380 cubic feet. So in a sense, I am dividing here and I'm getting the answer. You can also just divide the two numbers if you feel confident that when you divide these things, whatever way you do it, just make sure you do the calculation in a way that the feet cubed have to cancel and the hours have to survive. So in this case, we would do 1380 divided by 2500. 1380 divided by 2500 hours, which is approximately whatever Nicholas said there, 0.552. Whoop, which is approximately 33 minutes.
Sir,
Yes.
I also did what you taught us last week,
Uh-huh.
which was to put 60 minutes over 1 hour,
Nice, 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 nice.
and then that just simply cancels out and gives you the answer without approximating.
Yeah. So what Nicholas is saying is you can do this with less steps or more compact by converting it to minutes right away. So I'm actually gonna do so this is the way that I first answered it, and let me answer it a second way now. So the alternative is you can do this. So in discussion with what Nicholas is saying there, we can multiply further and say that there are 60 minutes for every hour. So it's like a triple. And then you can just go immediately and say that's 33 minutes. That's my backup plan. So both of these ways are nice. If I was a student, most when I was a student, sorry, most likely I would have answered it this way. Not be I like this way better. This way is really nice. But the reason I would have answered it the first way is because I'd say, okay, I know how to do hours to minutes. That's not too stressful for me, so I'll just like back off on that. I answered Cosimo and Norris's question in the chat, so hopefully that's good there. Awesome. So anyway, you're not going to get too many oddball kind of questions. The questions on the test in terms of the volumes, I don't think they're very hard. I don't like to give too many hard questions on stuff that's based on the week before, because it's too close to the test. I mean, I remember as a student, and I mentioned it probably in the past to you, where I remember, I tell you right now, there was a one course in undergrad. I had 40 courses in undergrad, half courses like how you have, and there was one course. It was the last day of school, like the last lecture, the day before, like not the day before, but the lecture before the final exam. And the professor was talking about transmission lines. It was an electrical course, an electrical engineering course. And the professor's talking about transmission lines. I'm like, oh, that's cool, you know. And I really didn't get the whole idea of it. Like I wasn't really perfect at it, and there was so many things to study for. And I go, oh, I don't have to worry about it. It's probably what's the worst that could happen? Like what? One question? You know, I'll get everything else really well, and then I might screw up one question. Turned out, turned out 20% of the final exam was on transmission lines. Okay, so basically, the professor made the final exam, 20% of the final exam on one lecture. To clarify better, in 40 hours of teaching, he did 2 hours on transmission lines, which is 5%. So 5% of the material delivered was 20% of the final exam. So go enjoy that one, right? I was pissed. I was so mad. Anyway, that's why I said if I ever become a professor, and I'm happy to be one, I would never do that to my students. So we can thank that professor for that. Anyway. Okay. Ooh, this one's got two parts to it. So I've highlighted A and B. I just wanted to make sure that you recognize the two-part question here. So first we're going to find out the volume, and then we're going to find out the mass. So this is where we're going to use density. So what I'll do is I'll answer the question here. So part A is about volume and part B is about density. So A, and then B, mass calculation. There you go. So how about I give you like a minute or two to do part A? It's actually asking for the length of the box, so it's not asking for the volume. So when I say volume calculation, I don't necessarily mean you're getting a volume as the answer. I just mean that there's a calculation involving a volume. So you should have a setup like that. That sounds right, Huria. That sounds right. I have the answer key open up on a separate file, just the final numbers to make sure that we're all good. But yeah, the answer key says 25.2, so you're good to go there. Good job. Let's put all the numbers here. We have 3,500, sorry, 3,000 I meant, and then we have 8.5 and 14. It doesn't matter which one is 8.5 and which is 14. Yeah, go for B now. It doesn't matter which one is which, just as long as you do things consistently. So I'm going to show some intermediate steps because I'm sure it will make a few people feel happy to see that. You don't have to write the units on each step. So if you're seeing me write all these units and you're getting annoyed, you don't have to write the units down. I like to write the units down because it's nice to see how things evolve. Like to see how you can actually compute and also keep track of the units at the same time. So in this case, we'll have 3,000 centimeters cubed and then 119 centimeters squared. You see how the centimeters cancel? That's what I'm trying to say there, okay? They cancel, so we know that we've done things correctly. So if we divide those numbers, you get 25.12, or sorry, 25.21. I'll just leave it as 25.2 as per Nicholas and Huria's answers. So there we go, 25.2 centimeters. I like this question because it's written well in the sense that if you make a mistake on A, it doesn't destroy your answer for B. So let's say that you didn't get the answer for A correct. You can still get the answer B correct because they are, in a sense, disjoint. The length is not going to affect your answer for B. In part B, we have a density calculation. It was a formula that I highlighted in the notes, and I'll repeat myself with it here. And I don't want to use symbols because people are not going to remember symbols. They're going to remember words. So density is equal to mass divided by volume. Okay, you can just use English. Just put words down. If you don't want the words, of course, you can just write D equals M over V. But then it's on you to remember what all those symbols mean. So for that reason, I'll just write it in English so that we all are all in a comfortable position to remember the usage. In this question, we're told the density, it's right here. You see it up here? The density of steel is 7.8 grams per cubic centimeter. So that's going to be equal to 7 Just a second, Huria. I'll catch up to you. I'm trying to type in some weird units here now. Mass is unknown. That's M. Then the volume is 3,000 centimeters cubed. Now, if you don't mind, I'm just going to scroll down at this point. I'm going to scroll down and because keep the nice big font on the screen. So we're gonna multiply both sides by 3,000. So we can say that M. That sounds right. That sounds right. 23,400 is correct for the grams. So the mass is going to equal 7. The density. So that's 23,400 grams. But in the question, I want kilograms. So that one's an easy one to fix. So that's why I'll just not really discuss it too much. 23.4 kilograms. It's all good. I think there's a fire truck going by or something. I hear it outside. Can you hear a fire truck outside? Yeah. Yeah. Okay, now don't worry, we're not going to be doing the Doppler effect in this class. That's how when the Doppler effect is how the sound, how you perceive the sound of the fire engine as it goes by. It's related to the Doppler effect. Anyway, this question here, you might be like, you know, John, oops. You might be like, hey, John, I don't like this part. I don't like how you wrote that. Could I do this differently? Absolutely. So let me show you how to do it differently, okay? Because that looked weird. What you can do is you can take the density formula and manipulate it and say that mass is density times volume. Okay? So I think that's the better choice here. I think this is the nicer version of the formula. So sometimes it's better to just manipulate the formula first before you start playing with it. So in this case, that would definitely present a much more appealing way to write it. I'm just going to touch that up for a second. The first way that I wrote it was more like just anticipating the units and the conversions. Because as with the question with the cubic feet per hour earlier, you can just take the question here and look at the units and manufacture the answer by just thinking about how to put the units together. It's almost like you're playing Tetris with the units. Do you kind of see the analogy of playing Tetris, how you have to rotate the piece and fit it in? I'm just rotating the units around. Yeah, exactly. Just try to trick those units to canceling. Yes, that's exactly it. Yeah. It may definitely trick some people. That's why definitely the formula is a safer bet. But if you don't get confused by it, then you try to do it that way, and then you don't have to remember as many formulas. Yeah, I don't want to trick anybody too much, Nicholas. Yeah, hopefully this is not too stressful. Okay, let's keep on going here. Let's go to question 4B. It's nice when you know how to manipulate it, though. For those that can't read this, yeah, that's basically it. You know what? In all honesty, try to do it both ways. Get it with the formula, and then get it with just the unit manipulation, and then it really builds your confidence. This measurement here, if you can't read it, it's 2 inches. Okay, I just want to put that in there. All right, so now it's up to you to figure out the volume of this shape. So I'll give you 2 minutes. I'll turn the mic off for 2 minutes and just try to do it on your own. Feel free to type your answer in the chat. Perhaps what I want you to do in the chat, let's do it in 2 parts. Let's call the upper shape 1 and the lower shape 2. So what I want to see in the chat is the volumes of each of those shapes separately, like volume of 1, volume of 2. Let's get those shapes separately and then we'll add them together. So you got 2 minutes. So you're still working on it. I'm just trying to set this up here. Thank you for the presentation that I'm seeing everybody's answers. I had to step away from the file for a second because it was glitching and I couldn't type anything. Kind of frustrating anyway. So to catch up here, I'm not going to write the units. 6 by 6 by 2 is 72, and that's in cubic inches. So that's okay. And then the second volume is 13 by 13 by 6. Thank you, Nicholas, for the details there, and everybody else as well. And also, it's really nice to see everybody kind of chatting it up and figuring it out together. So 16, 13, 13, 6. 13 by 13 by 6. Under normal circumstances, I could do that in my head. I'm trying to do catch up now. So then the volume is going to equal V1 plus V2. So if we add those together, we get 1086. No tricks to this question. I mean, in a sense that you're not being asked to like find out the mass and deal with density or something like that. No games there, okay? Just whatever it is there. But we could definitely turn it into a density question or a mass calculation if the question was given either of those quantities. So what differentiates an easy question from a tougher question? Just to take a step back, let's talk about what I perceive to be an easy question in terms of because I'm writing your test. This is an easy question, okay? Find the volume of a box. Sure, no problem. This would be considered a medium question because it's like a unit conversion with the volume. And what would be a hard question? Well, I don't think I'm giving you any hard questions on this test. In all honesty, I really am not giving you hard questions. Your test will be about quantity, not quality. It'll have quality in it, but it's mostly going to just be like unit conversions. So that'll be a big chunk of your test. That's true. They can be tricky at times, but if you look in the test review, you'll see that I tell you by category what the conversions are. I think we're going to do one more question before we take a break. Here we have a parallel solid, or a prism if you prefer. So I'll just say here, parallel solid, prism. The volume is equal to the base times the height. So that's what we're working with here. It wants you to find the weight of the block. So the weight of the block is like the weight is going to be in pounds. Okay. Now I mentioned to you mass and weight are not the same, but when it comes to the imperial system, the units for mass and weight are the same. So when we're trying to find out the weight of the block, ultimately our final answer that we're looking for is pounds, or pounds of force. So we're going to need two formulas. I've given you the formulas on the side here. We have the prism or parallel solid, and then we also need to know the density formula, which is density, oops, is mass over volume. Or V equals M over V, or M equals dV. However you want to write the thing. I'm just writing it all the different ways to make you feel happy. But those are your formulas that would be useful here. Let's take this diagram and really just zoom in on it because it's hard to read. Okay, so these smaller units are half inches everywhere. There's half inches everywhere. So if you're like, how do I start the question? Let's get your foot in the door here. So this is, I said here, base times height. See base here? I'm going to outline the perimeter of it. So the base is this shape here. It's this notched looking rectangle. So what you need to do is find this area. That's B, okay? And what's the height? Well, the height is the depth in this case. That's the height. So I'll turn the mic off and I'll give you, I don't know, maybe like 4 minutes. Not for the whole question, just to get that volume. You got 4 minutes to get the volume. Okay, I'll start prepping the answer. In the meantime, you can just keep on working on your own. Yeah, we're looking for the mass. So I'm just going to do some work on my own here. You do your own thing still, and we'll take it up together shortly. Okay, first things first, I found the area of the base as follows. I found the area of the blue rectangle all the way through. The blue rectangle is 4 inches by this. Now, what is that overall length there? That length is going to be 2.5 plus 1.5 plus 2.5. So 2.5 and 2.5 is 5, and then 1.5 more is 6.5. So that's why I got 6.5 there. Then you have to deduct the area of the notch here that's cut out. That area is 1.5 by 1.5. So when you take all of that into account, you take the big rectangle minus the small rectangle, which is the gap or the hollow part, and you get 23.75 square inches. Can someone confirm in the chat that they agree with that? Anybody agree with that number? Thank you. Let's get the volume now. Whoops. Volume of prism. V equals base of prism times height. So we take 23.75 square inches, and the height is 1 foot 6 inches. Ew, not cool. So 1 foot 6 inches is 18 inches. Confirm. Thank you. So that's 427.5. I think it's 23.75 because you do 1.5. 1.5 times 1.5 is 2.25. So it's going to have 2 decimal places. Yeah, it's, of course, Marco, you can do it there several ways. You can do several ways, okay? Absolutely. So some people want to do this, they can cut it up into different shapes. I'm just trying to show you how to do it without cutting it up into shapes because it's the least amount of time. This 18 inches here, that's okay. This 18 inches here, I'm going to highlight it in red so that you connect it to earlier stuff. See, we have here feet and inches. We don't want that because everybody else is in inches. All the other units are in inches. It would be a natural thing here to make the length or depth if you want. Thank you, Senjit. You want to make that 1 foot into 12 inches. So 12 and 6 is 18. So now we have the volume. Now we can proceed to figure out what the mass is. Notice that the density is given to us right here. See, the density is 0.3. Okay, that's 0.3 pounds per cubic inch. So let's do that now. So I'll just write some stuff here. The density is 0.3 pounds, oops, per cubic inch. So we can get the mass by taking the density and multiplying by the volume. I will catch up to you. So density is going to be, oops, 0.3 pounds. I know these questions will go by a lot faster, but I'm trying to give you time to practice them. And I'm also trying to type them out nicely for you as well. So it's like there's 2 competing issues here in terms of being faster to teach you this stuff, or to at least review. I'm not really here to teach you these things today. I'm here to just facilitate your being able to do it on your own eventually. So yeah, 128. I'm just checking the answer key. That's the answer, so we're good to go here. The answer is indeed 128 pounds. I'm just going to highlight that and give you a break. My goodness, it's almost been an hour. Wow, that went by quickly. There we go. All right. Take a break until 10:05. Give you a little bit extra today, and then we'll continue the class after. So break until 10:05, okay? So this example continues under the same style as the previous question. We want to find the volume of a parallel solid, or a prism if you prefer. And what that involves is calculating the area of the cross section, which we'll call the base. And then also we're given the length of the channel, which in this case is 14 feet. And that would be like the height. So this here is going to be 14 feet. That's 14 feet right there as it extends out. I've not drawn the best picture, but hopefully you can see the perspective in the diagram. So how do we find the area of this base? There's lots of ways to do it. Some of you might break it up into shapes, like 3 shapes like that. 1, 2, 3. You could also do the big shape minus the small shape inside the hollow part. I'm going to do it that way. So I'm going to take the area of the large square, and then I'm going to subtract inside here the area of this empty rectangle. So that's the approach that I'll take with this question. So the larger shape is 2.5 inches by 2.5 inches. And then we're going to deduct the hollow part. The hollow part is going to be a little bit more annoying. So perhaps I can get some assistance from you with that. We need this guy here, and we also need this length here. Whoops. Don't mind the computer here, it glitches. As soon as you start recording, it's so terrible at drawing. Anyway, so we have 2.5 inches minus quarter minus a quarter. So yes, that's 2 inches. Thank you, Marco. And thank you, Nicholas. That's 2 inches. And then over this way, I think it's not 2 inches. I don't think it's a square. I think it's going to be 2.25 inches. It's 2.25 inches. Because you're taking 2.5 and you're taking away a quarter. So can someone confirm that in the chat? They agree with that? Thank you. Anybody have that calculation done already? That's 6.25 minus 4.5, which is what, 3.75 or something? I'm just trying to do it in my head now. Not worth the effort when I have the calculator right in front of me. No, just the one side. Just the one side. So there's the area of the base. The height is given already. The height is going to be 14 feet, but we need to convert something here into inches. So we'll multiply that by 12. So 14 times 12 is going to be 168. Thank you. And we get our volume now. So that's 168 inches by 1.75 inches squared. And checking the answer key here, 294, that sounds right. 294 cubic inches. I hope you can appreciate why I went a little bit quicker on this question, because we've seen the formula already in the previous example, and really the challenge with these questions with parallel solids is getting the correct area for the cross-section. Once you have the cross-sectional area, then the remaining part of the question doesn't really become too dangerous. So I'll give you just another 30 seconds to jot down any other information that you need, and then we'll do another question where the cross section. I'm kind of bored of rectangles, as I imagine you're probably bored of rectangles now. So we're gonna do another question that involves a triangular cross section, and then after that we'll shift our attention to different examples. If you're wondering, if you're asking yourself, have we covered all the things that you need to know for the test? In my honest opinion, I do believe that if I were to stop the class today, even not have class Friday, that you would have enough information and be ready to go for the test. So if you're good with everything we've done up to this point, I honestly believe that you are ready for the test. You should still go and do exercises and practice all your homework and build up your confidence further, but I don't think you'll see anything outside of what I've shown you up to this point. So here's question 9. It's another parallel solid, or prism if you want. So you notice that immediately I'm just recycling the formula a lot. I like to recycle, as you know. So, right, well, who wants to write the same thing over and over again? I want to focus on bigger things. Let's just find the volume of this thing in cubic feet. So we want to make sure that our measurements are therefore in feet as early as possible. Actually, I'll color it in green so that it's different. So I'm going to just scroll down to the actual figure and zoom in on that, because really this is what we have to play with. This is question 9. So if you're wondering what question this was, I'll just put a 9 here. I'm doing question 9. And anyway, we need to find the area of the cross section. Now, what shape is that cross section? Well, it's a triangle. At no point in today's class did I tell you or remind you what the area of a triangle is. So yeah, the answer is it's half base times height. Thank you, Nicholas. Thank you for keeping the ship afloat today. Um, so let's do that here. Half base times height. But we need to convert the base and the height into feet. So I'm just going to go first here and deal with that stuff because the units are not the nicest. So base of triangle is going to be 2 feet 4 inches, which is going to equal 2 plus 4 over 12, which is 2.333. I'll put 3 decimals, it's fine. You can put less decimals if you want. I mean, just keep it on your calculator, okay? Like, try not to throw away all the stuff off your calculator. So let's just put 4 decimals because the more the better. Better to put the exact number in there, but we're not going to talk about that too much here. Height of triangle is 1 foot 6 inches. We saw this earlier. Remember that 6 inches is half a foot. So I'm not going to give you the extended version there. You don't get the remix there. You just get the original. So we're going to go half here. The base 2 point, put lots of 3's there. And 1.5. And, oh, we'll just put it exactly. Yeah, so 1.75, is that what we have? Thank you. That's 1.75 square feet. If you want here, you could just put 2 and a third. If you want here, you could have just put 2 and a third if you like your fractions. I actually like that better, but I already wrote 0.333, so I don't want to confuse anybody further. And the height, we'll do the same thing here. Thank you, Huria, for factoring in there. So we have 2.5 feet, sorry, 12.5 feet. So we have 1.75 square feet, 12.5 feet. Question 9 is 21.8. I got 21. Can someone confirm 21 something? I'm trying to do it in my head. 21.8, 21.9. Anybody else get that? The answer key says 21.8. Looks like it's closer to 21.9. Thank you, Nicholas. So anyway, there's another one. There's lots of these to do, and if you honestly are enjoying doing these kinds of questions, I encourage you to try them all in the book. Whether or not you might see the ones that are missing on a test, it's still fun to do. I just want to put that out there so for everybody to know, okay? When I prepare for the lecture, I go through the notes and I just pick questions randomly. I try to pick questions and not duplicate myself too much, and I try to pick questions where where I try to give a variety as well, and also things that students have had trouble with in the past. Now, when I design a test, I do not look at the lecture notes. I look at the original booklet, insofar as that I don't. Um, I try to make the questions unrehearsed. So what I mean is that I don't look at the book and say, "Oh, well, I did that one in class, so I'm not going to put on the test." I literally randomly pick questions also for the test. So there might be a chance that there's a similar question. There might be a chance it's not the same question. Like it's just I don't want you to have that worry that oh just because you did it in class that it's not on the test, or just because we did it in class that it is on the test. I want that variable eliminated from your thought process. Just do as many questions as you can. That's what the preparation is for this test and for any test. Okay, we're going to move on now. We're going to jump to question 12. Here we have a cylindrical support column. Yummy. Okay, so we have a column and we have to find out cubic yards. So let's do that here, okay? Volume of a cylinder. Again, you should have these formulas handy as you prepare for your test, but the volume is a pi r squared h. Maybe I'll write that with lowercase. Looks a little bit nicer. Like that. Let's see what information we are told. So we're told the following. We're told that the height, so the height is given, the height is 15 feet. The question is asking for cubic yards. So I'm gonna do the conversion of cubic yards at the end. Although 15 feet is easy, it's 5 yards. We can just let's do the conversion at the end, okay? Just to practice that. Let's do the conversion to cubic yards at the end. The reason that I don't want to do it now is because if I talk about the circumference here, I'm going to introduce some other funny stuff. It'd probably be more efficient to convert to cubic yards at the end anyway, because it's only one conversion versus two conversions otherwise. We need to get the radius. So we don't have the radius here because we're given the circumference. So we have to dig back into our area calculations for circles and perimeter. So we know that their circumference from last week is 2 pi r. So we know that we have 8 equals 2 pi r. We know that r equals 8 over 2 pi. And you can turn that into a decimal as necessary. So 8 divided by 2 divided by pi is 1.2732. Let me know in the chat, how do you feel about what I just did here? This thing here, how do you feel about circumference and getting the radius? Are we good with that one? Are you good with that one? Okay. So in the formula, for the volume, we need the radius and the height. However, the question doesn't give us the radius. It gives us the circumference. So the circumference of a circle is a formula that we did last time, and it's 2 pi r. So that's straight from the notes. So what I did was I plugged in 8 for the circumference right here, and then I needed to solve for r. So I divide both sides by 2 pi. So that's how I got this formula here, r, this final step here, 8 divided by 2 pi. Once you divide 8 by 2 pi, you get 1.2732, which is your radius. Now we're good to go. Got the volume going on here. So we have the volume equals pi r, whoops, squared times height. So the volume is approximately Can someone confirm 76? Anybody else get 76 something? Anybody else get 76.39? Thank you, Marco. Okay, the rest of the question is a unit conversion. So we're going to review unit conversions now. So we know that if you have cubic feet, 76.39 cubic feet. We want to go to cubic yards. I'll do it with 3 separate ones. Remember the little play, the game that I played in the past? This is from prior to intersession week. I know that 1 yard is equal to 3 feet. But that's not good enough because it's cubic feet here. So I'm going to copy this thing 3 times. So essentially, you need to divide by 27. So if you divide by 27, I'm just double checking something, then you get 2.83, which is the right answer. Sweet. That was exciting. So anybody that did this question, if you wanted to go to yards right away, be my guest, okay? Do it. Go first, go right to yards. Don't even waste your time. The reason I chose not to do it is because I just wanted to do one conversion, which is at the very end. There's other reasons which are more subtle, and they have to do with mental math. I always like to think about a question. I'm not trying to say I'm going to get the full correct answer to 2 decimal places in my head. What I'm saying is I want to see if I can get the answer reasonably estimated. Can I get a nice estimate of the answer without touching a calculator? And for me, that kind of thing would be to not do any conversions until the end. Like, see this number here? 8 divided by 2 pi. Pi is roughly 3, let's say. So that's about 1 1/3. I'm off, obviously. I'm off because it's not 1 1/3. It's 1.27. But I can do 1 1/3. I can square that. That's about 1.69. I can multiply by 3. That's about 5. 1.69 times 3 is roughly 5. 5 times 15 is 75. I would have guessed without touching a calculator, I would have estimated the volume at 75. And then I know to go from cubic feet to cubic yards is to divide by 27. And I know that 27 is approximately 25. So 75 approximately divided by 25 is 3. So without touching a calculator, I would have said that the answer is roughly 3 cubic yards. This sounds like a lot of stuff to do in your head, and I can appreciate that it would be very annoying or intimidating. But if you can try to practice doing calculations and estimating them in your head prior to getting the answer, it will significantly boost your confidence and your mental math too. Because once your guesses start looking correct, then you'll build up momentum and feel super powerful when you're doing these questions. One figure that we haven't talked about today, which I guess will kind of complete the suite of formulas that we had, is the cone. So for that reason, let's do a cone now. Make sure we get a cone out of the way. You know, our little checklist. It's like you're playing bingo. You're playing bingo with volumes. And to finish off the bingo card, you need to get a cone. So here's cone. So once we do this one, we've covered all the shapes. And we've already talked about density, so we got that out of the way too. All right, a large funnel, here it is. And you're asked to find the volume, capacity, which is volume in liters. So one thing before we start, a unit relationship that you need to know, of course, is that 1 liter is equal to 1,000 milliliters, which is equal to 1,000 centimeters cubed. The milliliters part doesn't really like concern us right now. I just wanted to put that out there because this is a conversion that is very useful, and we're talking about water, okay? We're talking about capacity of water. So you might be like, John, automotive antifreeze is not water. It isn't water. Sometimes though, if you ever have like, you're low on antifreeze, you can put, if we're talking about engine, so this is antifreeze, yeah. So if we're talking about that, that's like an alcohol. So an alcohol is very close to density of water, so it's not that far off. But anyway, the question is to find the volume of that. So we need the volume of a cone. So the volume of a cone is equal to a third pi r squared h. It's a third of the cylinder. In the next math course in January, there's one chapter which is on surface area and volumes, and it's I wrote that chapter, and it's a way more there's a lot more stuff going on in that chapter. But one of the things I do go through is all of these volume calculations, and I try to summarize them. So if you like this kind of stuff, you're going to see more of it in the next course. And I did mention that earlier, but for those that may have arrived late today, I'm just putting it out there again. So here's our cone. What's the height of the cone and the radius? Okay, what's the height of the cone? The height is easy. That's 24. Sorry, that was rhetorical. Everybody can read the height right off the picture. But what's the radius? Your turn. What is the radius? 9. Yeah, 9. I think you just hit the wrong number on your keyboard, Huria. Thank you. Okay, so here we go. We got all the stuff. We got all the goods here. The volume is equal to 1/3 pi r, which is 9 centimeters squared. Height is 24 centimeters. Learning how to type, you know? Pi divided by 3 times. Anybody have an answer there? Anybody have a quantity there? Did anybody get 2036? Thank you, Nicholas. Yeah, 2036 centimeters cubed. We'll just divide by, this is metric. In the metric system, you don't have to give me stories and explanations. Divide by 1,000. Because metric system is powers of 10. So powers of 10, divide by 1,000, multiply by this or whatever, those things you can do in your head. If we divide this by 1,000, we get 2.04 liters. That's actually a lot. This must be a gigantic funnel. Because I don't know about you, but the funnel that I use to put my antifreeze probably couldn't fill up a bottle of water, a small bottle of water, 500 ml. This is a gigantic funnel. A bottle of antifreeze is roughly 4 liters, I think. Usually those plastic ones you get at the stores, at the gas station. I think it's like 3 or 4 liters maybe. This cone's gigantic. It needs to calm down a bit, eh? Anyway, all silliness aside, does anybody have any questions about this cone calculation? How do you feel about the cone? Are you sick and tired of cones? How did I get 9? I took 18 and divided by 2 because the diameter is 18. Okay, I'll just save the file and then we'll move on and hopefully hammer out a couple of more interesting questions. Questions that are not as clean as other ones. This question would definitely be on the much harder side. This question's got a lot of things going on. So if this was on a test, believe me, this would be like at the end of the test. It'd be one of the hard questions. I'm not saying it's on your test though. I'm not doing that to you. The main thing here is that you have to find the area of the base and multiply by the height. So this is a prism shape. This is a prism shape. So I'm going to shade this thing in here, okay? See this area here? That's going to be the area of the base. And then this is the height. So we need to find the area of the prism. Sorry, the area of the base of the prism. So let's just go here and talk about that. Okay, this is a parallel solid or a prism. Well, it's 130, okay? You see the 130? So we're gonna have to find the area, the cross-sectional area is gonna be a bit weird. Just get the easy thing out of the way. The height of the prism is 5.42 inches at the happy face. The base area, B, is a sad face. So we got to figure that out now. I'm going to do some drawings here, and hopefully we can see how it looks together. This is 130 degrees. I know it's not the scale. I understand that it's not the scale, but just bear with me that you can appreciate the setup here. The area that we're trying to find is in green. That's right. That is very good. Temirlan, that is excellent. So read Temirlan's comment while I'm learning how to color. I'm learning how to color here. It's very exciting. It's therapeutic. It's not me that's this slow. Trust me. It's the software. I'm taking ownership, but that's the software. Anyway, the outer radius and the inner radius. We need these radii. So if I take 726 and I divide by 2, what do you get when you divide these by 2? Can someone give me some numbers on those? When you divide by 2, what do you get? What is this, 3.63? Can someone confirm? Anybody there? Thank you. And then this one will be 2.44. Awesome. So that's these measurements here. This is 3.63 inches. My goodness, it's so slow. I'm so sorry, everybody. You have to watch me drawing this thing. I swear, if I turn the record off, this thing is lightning fast. Anyway, we want to find the area of the shaded region. We need to go back and talk about sector areas. So I'm just going to talk about the area of a sector and remind you about it. So we'll say here that the base area is equal to the area of the one sector minus the area of the other sector. From last week, we talked about this already. The sector is as a fraction of the circle. That would be, I'll put it like this. I'll put theta over 360. This is the formula for the area of a sector. Just excuse me for a second. I'm going to put that on the side. Thank you for participating on these calculations. It's making my life a lot easier to talk to you. I'm not focusing on the symbols. So anyway, the area of the circle sector is that. It's I'll just put that right there. And I will catch up to you. As you can imagine, this is really, really, really painstaking to write. So the large sector is going to be 130 over 360. That's in degrees. Pi times the outer radius, which is 3.63. I'm not going to put the units this time. Minus, and then do the same thing. Can someone confirm Nicholas's answers? Thank you, Nicholas. Can someone confirm those answers so that we don't get too rattled here? I can confirm the first one, Nicholas, 14.95. Thank you for that. And then the second one, I'm doing it right now as well. .75 is good. Well done. Nicely done there. So let's just chop this up a little bit. So that's going to be 8.20 inches squared. Okay, well that was exciting. So we have the area of the sector minus the area of the sector. If you're wondering, what is this shape called? It's an annular region, like the word annual, okay? It's an annular region, or annulus, or a portion thereof. So now we're going to find the volume. So the volume is equal to BH, which is equal to 8.20 inches squared. Whoops, I had a space there. Times 5.42 inches. And okay, I'll take it on what you have there. So I got 4.6. I don't know. Oh, I typed it in wrong, that's why. No, 446. Can someone confirm, is it 44.4 or 44.6? We need a tiebreaker. We need a tiebreaker. Anybody there? Okay, I'm taking Nick. Oh, I'm getting double Nicholas. I'm getting Nicholas and Nikolaos. So I'm getting double nicked. Okay, this is dangerous. I need to back off now. The Nicholases are multiplying. Danger. So we have 44.4 inches cubed. All right. Now we need to get the mass. So we're almost there. So when they say weight, they're really talking about pounds here. So let's finish off the question and say that mass equals density times volume. So the mass is equal to 0.28 pounds per cubic inch times 44.4 inches cubed. So what made this question more difficult was the presence of a unit conversion and then a volume calculation and a density calculation. Lots of many parts, okay, and lots of moving parts here. But if you can separate it and just kind of divide and conquer, so to speak, then hopefully it's not as dangerous as first thought. Okay, it's a great question. I can just tell you flat out that this is not on the test, okay? I said that I know that this question for sure is not on the test. Not because you can't do it or whatever. Yeah. So Nicholas, you don't have to stress too much about this one for a test, okay? I don't like having questions that have a lot of moving parts to them. I like to have the question have like something with a follow-up. You know, that's what I'm talking about. It's next Wednesday, Joseph, in 1 week. Yeah, spread the word because I only see 19 people here. So next week's the test. If anybody misses that test and they're like, "Oh, I didn't know," I'm gonna be like, "Well, come to class," because I see who's in this audience here. I can look right now again, and if you're not on the list of people that I'm looking at right now, I see about 20 people or so. Then I have to say that I'm not going to be very sympathetic about that. So anyway, let's keep on going. I think we have time for one more. So 23. So this is a frustum, okay? Now a frustum is when you have a cone or a pyramid where you cut the top off. Yeah, I've been noticing that too, Nicholas. I think maybe I don't know if it's the topic or maybe people are like, "Oh, I'm doing well. I don't have to come to class," but it really is a strange situation. And if you're wondering, is it because it's online or in person or not online or whatever? It actually has nothing to do with the online. The idea of the attendance dropping off after intercession week is actually a phenomenon that for some reason happens. I've seen it happening as long as I've been at the college, which has been this is my this is my ninth year here. Or well, I mean I was here part time and I'm full time, but I've been here roughly 9 years, and it's just a phenomenon that I've noticed. Anyway, I'm just gonna do this on the side here. I'm giving you a visual in case we run out of time. What you want to do is a frustum is when this cone here has the top cut off. Okay, so we're missing the top of the cone. So the question is, you want to find out the volume of that. We know the volume of a cone. Cone is something that we did earlier, and I'll recall the formula with you. So this is the big cone and this is the little cone. We're going to subtract the big cone minus the empty cone. But you might be wondering, how do we get some numbers to this? Because when you look here, we don't know this. Like we don't actually know the height. See that height there? So what we're going to do is use similar triangles. So I'm going to draw something here underneath. It's a cross section of what the cone would have looked like if it was filled. We're going to put some numbers to it. These kinds of questions are good for assignments, not so much for tests. But anyway, the height of the cone is unclear, but we do know some stuff here. We know that this is 15. This is 15 here. This is 9. And then we know the following. We know that this is 12. It would be very good to know what this is here. So I'm going to call that x. So we can use similar triangles here to figure out the value of x. Because once we have the value of x, then we can proceed. So I'll just say here, using similar triangles, I can say that x is to 9 as x plus 12 is to 15. Okay, so what am I doing there? I'll just say it here. What I'm saying is that this here is to this as, I'll do the other one in green, as this is to this. You see what I'm saying? The blue stuff has a ratio, and then the green stuff has a ratio. Not very fun to do by hand, but I'll just cross multiply that. 15x equals 9x plus 12. Again, this one here is not for your test. This is just for enrichment for now. And then the worst case would be like maybe on an assignment or something. So that's 6x equals 108. Can someone take 108 and divide by 6, please? We get 18. Is it 18? Can someone confirm that it's 18? Thank you. Okay, so again, anybody here that saw what I did on the side here, if they're panicking, this is not on your test. Just focus on it more as an exercise, an enrichment question. If we go now to the actual diagram, we can put some numbers to it. So if this is 18, then the whole thing is 30. So I know that this cone is 30 units tall, or 30, in this case, centimeters. That's 30 centimeters tall. And then the little cone here is going to be what x was, which is 18 centimeters. We also know what the radii are, so we're going to take those diameters and divide by 2. So this will be equal to 4.5. So the radius is going to equal 4.5. And then this guy, the radius is going to equal 7.5 because it's half of 15. So insofar as setting it up now, we're good to go because we've done all of the calculations, and we've done all the setup calculations, and now we simply have to do a volume calculation. So down here, this is our final step in the question. The volume will equal volume of the first cone minus volume of the second cone. The volume of the first cone is going to be 1/3 pi 7.5 squared 30. Volume of the second cone is going to be 1/3 pi 4.5 squared 18. That's a lot of writing to do on a calculator, so I'm going to just check it in. I'm just going to a different tab on my web browser. I'm going to go to Wolfram to do this because we're running out of time on this now. Hopefully Wolfram can interpret this correctly. Just give me 10 seconds, I almost have it. The answer should be 1385. For some reason, when I do it on Wolfram, I get 136. What did you get? Did anybody do this calculation? Anybody get the answer for this already? Okay, I just checked it again. I got 1385. Can someone confirm they got 1385 as well? I have a suspicion that everybody's done. They've tapped out. Sorry, I can't see the chat. There we go. Thank you, Cosimo. And Huria and Nicholas. Yes, beautiful. Okay, I did on my calculator. I got 1385.4. So I'm going to leave it as, if you got 1386, when you round it, it's all good. The answer key says 1385, so I'm going to stick to my answer because I like to just be like that sometimes. I'm going to be a baby and just do that. So anyway, that's enough for today. As far as you're concerned, what we've covered here, and maybe the last two questions as an exception, what we've covered here really puts you in a spot where you are test ready. So at this point, whatever we do on Friday is going to be just like dessert, okay? So Friday, as far as you're concerned, is a non-stress class. You're not going to be learning anything profoundly new for the test, but we're still going to work on some volume calculations because they're good to know. Also, you do have a test next week, but the week after you have an assignment. So what I'm doing here with these harder questions, that probably will be the main material for your assignment the week after. So just keep that in mind anyway. So I might, for your next assignment, the week after your test, I might just grab a couple of questions here, maybe on the tougher side, and give you those as food for thought. So anyway, thank you very much, everybody, for your time today. I hope I didn't suck too much out of your energy, and I hope you had a good time learning some math and reviewing some formulas. All right, I'll see you Friday.